Welcome everyone. Thank you all for joining this session where we are very lucky to be joined by Martin Packer from IBM, who will be sharing how we can gain architectural insight from SMF data with examples. As per usual, feel free to leave any questions you have in the chat box as we go along, and Martin will answer them during the presentation. Also, at the end, we'd be very grateful if you could leave feedback as well, and I will paste a link in the chat box where you can do that. And with that said, over to you, Martin.
Thank you, Piera. So actually, before we get started, there was one piece of what I think we in the trade call follow-up from last time. And I'm looking to see if either of the Stevens is actually in the chat here, has shown up, but he hasn't. But anyway, the question was, during an SRB or RP boost, is it only the LPAR that's getting the boost that gets the speed up of general purpose engines? Or is it all the LPARs? And the answer is it's only the LPAR experiencing the boost, which if you back calculate from that tells you a little bit about how speed on processors works anyway. And I'm not going to say any more on that, not now. After a few beers, oh, whoops, we don't seem to be doing that anymore. Okay, right, so this presentation is called So You Don't Think You're an Architect. And it would help if I could actually page forward. Right, so if you're a performance person, you probably don't think you're an architect. And you could well be right. But if you hide behind the definition of performance and capacity, I think you're missing an important trick or two. And the whole point of this presentation is to continue questioning how you use SMF data in ways other than performance, particularly so you can gain what I consider to be architectural insight. So it's all about SMF, but it's really following on from a slide in another presentation, which I called How to Be a Better Performance Specialist, which I think I've given several times at GSC and other places. And the notion there is, who says what you're supposed to do with SMF? And the answer is you who are doing stuff with SMF say what you're supposed to do. And frankly, it's a journey of exploration, seeing what you can get out of it. Now, this architectural insight, I think because we have the data, we are probably the only people in the shop who can actually get the kind of insight in a systematic manner that the data would give us. So the whole point here is you could be very valuable if you learn how to extract information with an architectural flavor to it out of SMF data, actually out of other instrumentation too, but let's concentrate mostly on SMF. So I'm going to give quite a lot of examples at various levels from the system level all the way down. And one of the nice characteristics is you probably have all this data already. In fact, if you, for the vast majority of the data, if you don't have it, if you're not collecting it, for example, SMF 30 interval records, well, shame on you really, because you really should be anyway. But here's going to be a bunch of examples of how this is really going to add value if you start looking at things other than pure performance. And I will say, when I do workshops with customers, I like to do what I call an architectural introduction, which started out as being really very brief. It was, who are you, who are we, here's the data, here's the systems we see. It's kind of built into an hour or so's worth of discussion with a customer, which is really, really good for hopefully earning trust. That's the only way I want trust, is by earning it, but essentially getting it closer to how it is to be, insert customer name here. You know, the challenges and the state. So it's a really very good investment of time at the beginning of any workshop I do. So, you know, there's a Wikipedia definition of systems architect. And I really want to focus on the line that says such definitions include break down the system into components, to component interactions and interfaces, including with environment, especially the user, and the technologies and resources to be used in its design and implementation. That's really the piece of the definition from Wikipedia that I'm going to lean on. But my point of view is this: it's not essential to exactly match that Wikipedia definition, but it is valuable to bring architectural insight. So this is really the starting point of, if you're going to say, am I not an architect, you could use that definition. But I really, as I keep saying, want you to think about how can I bring insight that's useful with an architectural flavor. Okay, so we're going to talk about various layers. We're going to talk about machines, Sysplexes, and Lpars, and then come down a layer to workloads and middleware. And then the bottom layer, which may not spend that much time on, is about application components. Free plug, I have even more fun with DDF presentation I'm giving later in the week, where we really will get quite low level with application components. And then maybe we'll revisit the question of how does what we're talking about in this presentation fulfill the definition of architecture. Okay, so I'm not going to take you through this slide in any real detail, except for to say we're going to look at SMF records at the top level, mostly from RMF, and then in the middle from SMF 30, and again some RMF actually, and then down into the detailed middleware componentry. Mostly when I talk about middleware in using their instrumentation, I'm actually going to be talking about the various accounting and monitor traces rather than the stats traces. So there's a wide range of SMF records we're going to meet. I frankly think if you're not collecting everything in the red and the blue, you really should be anyway. And we could, be judicious about collecting the rest, particularly the counting and monitor traces. So we're going to talk through a lot of this. So let's start at the top layer. So if we want to document machines, we want to start asking questions like, what machines are there? Well, I'm going to admit you probably know, if you are a customer, what machines you've got. It's kind of nice, though, to keep track of them in a systematic, instrumentation-driven way. So what machines have you got? What models are they? What's their configuration? And then questions like, how do they at the machine level behave? And one of the pragmatic ones, and I'm seeing a lot of this year in particular, and the back end of last year, is if I want to upgrade a given machine, how far can I actually get with that? I mean, the flavor this last year and a bit has really been end of life Z13. I've even seen an EC12, where you end up asking questions like, okay, so what's the future given that generation? But even if you're modern, do you have to shove another drawer in? Do you have to do something that might cause some kind of outage, and at what level? So at the machine level, there are some questions to ask. Now, this is a fairly standard diagram I build these days. Most of it comes from SMF, mostly from SMF 70 subtype 1, but also 74 subtype 4. It's a machine, and the way you read this is the various pools rank from top to bottom. So GCPs, then zips, then ICFs, then maybe IFLs. And I'm too lazy to write code to get rid of an IFL pool if there's nothing in it. The colors of the blobs, which are obviously Lpars, are the Sysplexes they are in. But there's a load of other detail in here. There is basically how many engines in the pool, how many engines overall of each type, how many Lpars are active, how many are deactivated, and a bunch of other things. I'm going to make a few points here. So the first thing is the name of the machine, which in this case is called box 2, actually doesn't come from SMF or from VPD. I put that in based on what customers tell me. The other thing that isn't available in SMF, unfortunately, and yes, if you want to put a requirement in, I would be very supportive of this, is the physically purchased memory. Now, my colleague Keith Henderson, who I don't see on the call, but anyway, he has some nice tooling that takes the VPD and tells me how much memory there actually is on a machine. So, this is a machine with 384 gig purchased, immediately available for use, of which the active Lpars have allocated 141 gig. So you could argue you could drive harder with data and memory if you allocate it to some of the Lpars. It's a bit more complicated than that, as we shall see. one of the other things I want to point out here is, and it's colored in red deliberately, is ZOS 2.3. If you have less than 8 gig online on the LPAR when it starts, it will give you a bunch of nasty grams, which yes, you can ignore, but you really shouldn't. So I like to highlight when I'm looking at this, is a customer going to be nudged into allocating more memory to the LPAR? So that may be a performance thing, but to me, it's quite interesting. The next thing is, and this is more performance really, but I like to view this from how is it to operate or run the ship perspective. So what I've done is I plotted at the machine level, and I think this is the GCP pool because it behaves like it, the utilization of the machine, all the Lpars in the machine added up. And if I do it across the set of days for which I have data here, and in this case, I think it's a whole week, you get to see some patterns. The first thing is you can obviously see Saturday and Sunday. This is usually how I guess what day of the week it is when I'm looking at the data, is that actually Saturday and Sunday behave quite differently in most shops from weekdays. But the next thing is if you look at the bundle of daytime utilization, it's reasonably consistent, and sometimes it's shockingly inconsistent, and sometimes it's shockingly consistent. So that bundle, if you like, of series, how does that behave? It is quite an interesting artifact. And we also see, as in so many shops, in fact, I can't even remember which customer this one is from, you know, a regular late evening peak and a variable morning batch window peak. Now, for me, those are anchor points to have conversations about batch and could you schedule batch better and different. But this is very much a snapshot of how it is to run this machine, which I consider half and half performance and architecture. And it's come from SMS 70 subtype 1. So, you know, that gives you some idea of what the pattern of usage is. Now, you can drill down, and this is actually from 72 subtype 3, workload activity report data. You can drill down into what drives those peaks. Well, you can indeed see that it's batch in the evenings, and you can see it's something called started task in the day. I'm seeing chat. Okay. Right. Somebody's got a network issue, unfortunately. Okay, so you can see what drives those patterns, and you could see day on day, yes, it's the same thing. It's always the batch, and it's always whatever WMSTC is. Well, you can drill down into that as well. Gives you some idea of what you're running and how it drives things. So to get to that, we're using SMF 70 subtype 1, and one of the things I touched on earlier was the coloring for Sysplexes. Well, coloring for Sysplexes works just fine for ZOS Lpars from some, as I say, from CPU activity, partition data, report data. But what about the coupling facilities? Well, those aren't going to have the Sysplex filled in the 70 subtype 1. So for those, you begin to need the 74 subtype 4 coupling facility activity data. So it's really a combination of those two that gets you to what is the shape of a Sysplex. And also from 74 subtype 4, you get a lot of other things, but in particular, you get distance. So I can have conversations with customers, and a good example of this is the one I'm dealing with in Brazil right now, where they have a bunch of machines with ICFs, and they're all very close together. And I can see that lack of distance from the 74 subtype 4 signaling latency number. But they have another coupling facility at 20 kilometers distance in the same Sysplex. Thankfully, it's inactive, but it's really part of a DR scenario. But you can get that kind of structural information out of the 74 subtype 4. And obviously the roles of those coupling facilities you can get because you can see the structures in there. So really a combination of 70 subtype 1 and 74 subtype 4 gets you a very high level view. I should also point out that in 74 subtype 4, you get the path types in considerable detail down to the adapter and port ID. So I can have a conversation with a customer about you're moving forward, you'd better get off InfiniBand 3 or whatever it might be before you do it, which is really not a performance conversation. It's more how do you move forward? Where are you on the journey, dear customer, kind of conversation. Okay, so if you put it all together, and this is actually from a customer a little bit east of me, not very east, a few time zones. You put it all together and you can build diagrams. This is not automatically built, by the way. I built this in OmniGraffle, where you can actually see the 4 machines in the 2 data centers. And you can see within the data centers, the distances of the signaling latency is 1 microsecond, which is approximately 1/10 of a kilometer. And you can see the 23 microsecond latency between the 2 data centers. So that's 2.3 kilometers. The 2.3 kilometers is a fairly solid number. The 1 microsecond, well, we've got 1 microsecond granularity on the number. So, that could be anything from 0.5 microsecond to 1.5. But it gives you some feeling here. We've got within the data centers machines very close to each other. And between the data centers, we've got some distance, which will have an impact on performance, but it also has an impact on availability. What was quite interesting a few years ago was I was working with a customer in the Netherlands who this data revealed 3 different routings between the 2 data centers. And the routings had distances that were different from what the telco had said. Now, it wasn't a consistent overestimation and it wasn't a consistent underestimation. It was a bit mixed. So I said to the customer, you might want to have a gentle, friendly conversation with your telco as to exactly what the routing is. Not really the intent of this, but it's a sort of non-performance conversation you can have if you're sufficiently nosy, because the data will tell you. So it's quite nice to be able to build a flavor of the Sysplex setup and the machine room setup from SMF. Okay, probably we should skip over this one. Right, so I alluded to this before. You can, from SMF 70, also get the inactive Lpars. And the way you know they're inactive Lpars is because they have no logical processor data sections. You get their names and the Lpar numbers, and that's it. You obviously get which machine they're in. Now, this to me is quite interesting and instructive, because the scenario that's quite common is you have on one machine an active Lpar called, let's call it SysA, and another machine you have an inactive Lpar called SysA, or something very close to it. And you can have conversations like, do you really intend, if this machine dies, that SysA will be recovered to this other machine? Not really a performance thing. You might just call it nosiness, but I think it's quite interesting. Now, the other thing about this is, I'm not going to go back several slides to the diagram where I said 144, I think it was, gigabytes allocated to Lpars out of 384. But some of that difference between 384 and 144, what's that? That's 240, might well be for the recovery of inactive Lpars. Now, we're not going to get the memory size for the inactive Lpar, but at least there's a warning in my head that says not all of that 240 gig is actually usable for the Lpars we already see on the machine. So no, inactive Lpars I actually think is part of the architectural story, or the operational story, if you prefer that. Okay, so another thing that's interesting, and this time when I started doing this, I was not able to get it out type 70, is, when is the machine, well, not necessarily just the machine, but when are the Lpars IPL'd? Are you the kind of customer, and there are a few of these around, who IPLs every week? Or do you IPL once a fortnight? And do you IPL all the Lpars when you IPL, or do you IPL a subset of the Lpars? Do you do rolling IPLs? Or have you not IPL'd in several months? that's quite interesting. How do you run things? How do we interpret which members are up and which members are down kind of question? Now, in my code, I use SMF30 master scheduler address space reader start time as a good signifier of an IPL. And that can go back months, even if I don't have data going back months. It's going to be in the type 30 records for the time period I have, even if the LPAR was IPL'd months or whatever ago. So that's quite a good one. And I don't think there are customers who are I don't even think it's possible to basically restart master scheduler address space without IPLing. There are people on this call who possibly can confirm or deny that, but anyway, that's a footnote. Relatively recent APAR for SMF70 RMF, which actually will give you the solid IPL time and date. So that's kind of handy. I don't think I'm about to change my code because it works just fine. But if you want an easy way and you don't want to mess with SMF30 for this purposes, you can get the IPL time. And you might say, well, I run the shop. I know what the IPL time and date was. Well, in large customers, and I can see dear friends from several large customers here, as well as dear friends from several smaller customers, people might not tell you. And it's better to be systematic and better have the data tell you. So that APAR might be kind of handy. But in any case, we've got a set of 3 machines here where you can see actually that all the LPARs on all the machines were IPL'd early in the morning, which sounds to me like a group-wide restart in DB2 terms and Sysplex-wide restart. And I might ask, well, why did you have to do that and not do a rippling IPL? But you can see the time stamps for when the reader start time for master scheduler address space was. So that seems to have all happened within a period of about an hour and a half, maybe 2 hours. You might just say that's tourist information. I don't disagree, but it can be very handy to have these conversations sometimes. Okay, so that's a high level view. That's really machines, Sysplexes, LPARs. The really interesting piece for me is to dive down into the workloads and middleware. And if I don't drink, I'm probably going to stop talking enforcedly. So just as the rhythm of CPU utilization is interesting, at the LPAR or machine level, it's also interesting at the workload service class address space level. And so are transaction rates. And for many transaction managers, you can get transaction rates out of the SMF72 subtype 3 workload activity report data. Now here's a fun one. In the 72 subtype 3, well, obviously the service class and workload and report class as appropriate names are in there, but so are the 32-byte descriptions or 32-character descriptions of the service class or the workload or the report class. It's a good idea if they're usefully described. It's a good idea if those descriptions are accurate. Probably not the best of ideas to stick the goal value in the description, let alone in the service class. Or where's my dear friend? He's not even here, is he? Oh, yes, he is. He knows who he is. But by the way, he's not alone in this. Lots of customers put the goal values in the description or put the goal values in the service class, and I'm finding tons of cases where those are just no longer accurate. I had one the other day where somebody was claiming in the description that 95% of transactions should end in a particular goal time, when in reality, what the goal was average of that goal time. That seems like an actual finger check error. But anyway, those descriptions could be useful. They should be accurate, and they do appear in SMF72 subtype 3. And if anything appears in SMF you send me, I'm inclined to use it, whether for comedic or actual useful purposes. So SMF30 gets to be really handy in this. It does things like allowing you to tie together service class and report class. So is a service class a subset of a report class, or is a report class a subset of a service class, or something else? The 30s allow you to tie that together to some extent. It also says what runs in each service or report class. So I have lots of discussions with customers about classifying stuff in WLM terms. So, you know, this STC high, what is the actual purpose of the thing? Now, there's a footnote here that independent enclaves, and I'm thinking WebSphere transactions and especially DDF transactions, don't really play so nicely with SMF30 in this regard. They do in another one, though. But before we get to that, the other thing I would like to see is, are there spikes in certain key address spaces, like the HSM address space or the catalog address space? So if I see those, then I'm inclined to think things. So for example, the HSM address space, if it spikes regularly, same time every day, I think there's either daily space management or daily availability management or both going on. And that might condition what we might say about events around it, like batch, like online, like on online day. But it's a structural thing. It's part of how you operate. If you have spikes in certain key address spaces at certain times of the day. And a really fun one is RLM. What on earth is going on if RLM suddenly spikes in terms of CPU regularly every day? Okay. Now, I held my fire a little bit on that last slide because the really interesting one to me is actually dump serve. So this is an example with a customer where dump serve spiked. Now, it wasn't CPU that spiked. It was, as is so often the case, the XCP rate that spiked. So, you know, I could be awful and say, what on earth happened at 9 p.m. on Tuesday, the 9th of October? And generally when I do that, I get an answer which is, oh, we had a problem with whatever it was, some kicks region or something that caused a dump. So, you know, people might not tell you on the operational side that there was some issue, but you could see footprints in the sand for that from the XCP rate for the dump serve address space. And I often do. Okay. So one of the really, really interesting and useful pieces of data in SMF30 address space records is the usage data section. So if we take some easy examples, KICS regions, DB2 subsystems, MQQ managers, each of those address spaces, well, DB2 subsystem is multiple address spaces, of course, you know, but each of those writes at least one usage data section record that says, hello, I'm KICS, or hello, I'm DB2, or hello, I'm MQ. They always contain the software level. So I can run a query, and I generally, well, this is built in now into my code, which says, you know, are all the KICS regions up at 5.6? The answer is probably no to that one. But well, do we have a cluster of I don't know, KICS version 4 regions? Because then I can have a discussion which says, what is it that's inhibiting you moving forward from KICS version 4 to version 5? DB2 subsystems is a good one. Customer I'm working with right now, they're all version 11, and I would love to know why they're not version 12. And similarly, queue managers. So the software level starts thoughts in my head sometimes about where is the customer on the journey. So you too, if you have usage data section data in, let's say, MXG or whatever tool you're using, can run a very simple query that says, tell me all the software levels for KICS or DB2 or MQ or IEMS or WebSphere or whatever it might be. Often, but not always, and this is where it gets really handy for me, you get the subsystem name. So for DB2 usage data sections, you get the qualifier, product qualifier is the DB2 subsystem name. So we're getting the beginnings of topology here. Now, you have to do a bit of work with MQ. So, for example, a batch job connecting to MQ, which isn't quite the oxymoron it sounds like, we'll have MQ01 bat C if the subsystem is MQ01. That's really not a difficult piece of programming to get the subsystem out of that, I would have said. So you can do things like understanding whether a batch job in particular, because this works for step end, job end records, as well as interval records, connects to a DB2 or an MQ. And you do it, if you're doing it with SMF30, this is without DB2 or MQ instrumentation, which is a good thing. And you get which one it connects to. I will say, though, that we tend to supplement this with information other than the usage data section that tells us about components. So, for example, a ZCX address space will tell you it's ZCX from the program name. RLM certainly will do that. Footnote here, RLM won't tell you whether it's an IEMS or a DB2 RLM, but nonetheless, it's an RLM. Kix data table server and a bunch of other Kix Sysplexes related address spaces, they are readily identifiable by the program name. And maybe you need to go to the Unix program name in a few cases, but generally speaking, you can, between the usage data section and just the program name, figure out what an address space is for many, many common pieces of middleware. Okay. So here's an example actually of looking at the software levels from SMF30 usage data section. So if a piece of software, and it doesn't matter whether we're talking about an IBM piece of software or some other vendor piece of software, uses the IFA usage macro, then we get a usage data section. Now, some products that use it will appear in SMF89, but that won't be at the address space level generally. So there are some products that you don't see in the 30, but you do see in the 89. Which is worth bearing in mind. Now, here's just an example where we have a customer where all three it's 4 Lpars, isn't it? I can't see the right. This is the one case where I really want to see the right-hand side of the screen. Where you can see by system, all of them are ZOS 2.3. A couple of the systems actually are running Kix, and they're both at 5.2. 3 systems run DB2 at version 11. This is quite old, obviously. And 2 of them run MQ version 8, and a couple of them run WebSphere application server, not usage. So the not usage is kind of interesting in terms of I think this must be a ZNalc Lpar or something like that. But this is something you can readily extract from the 30s. Okay. Also from the 30s, you can actually drill down, as I said, into utilization. So you can, for example, on the left-hand side, we've actually got 72 subtype 3 data. You can see the CPU in the started task service class that we saw a few slides ago is essentially driven by a service class called STC Kick. I don't know why it's not called STC Kicks. I mean, you've got the space there, but never mind. So what's driving that? Well, on the right-hand side, you can see, well, really 15 out of the 25 Kix regions in that service class contribute 95.5%, roughly speaking, of the CPU. So here's the big guys. Yes, you can obviously get the little guys too. And maybe you can see some kind of cloning here because some of the regions go up and down together in a similar sort of pattern. Now, maybe that would be better illustrated with a line graph, because if all the series align with each other with a very tight bundle, then that would be evidence of cloning. Now, to me, cloning is an architectural artifact because it says things about availability. How many customers have cloned Kix regions or WebSphere application server regions or whatever for availability and spreading the load purposes. And by the way, while we look at this, if you look at the right-hand graph and you look at the left-hand side of it, you can see some of these regions approach 100% of an engine, if not more. Now, given this is kicks, you should be asking questions like, well, how much of that is actually on the QRTCB? Let's hope not very much of it is actually on the QRTCB. And the rest is, let's say, on TCBs connecting to DB2 or MQ. So that in itself can be an interesting, actually that's an availability story, because what happens when the QRTCB is overloaded, you might consider that a service degradation. And what I've just said kind of sounds like a performance statement, but it also sounds like an availability statement, and that's part of the point here. Okay, so let's talk about DB2 a little bit without talking about DB2 instrumentation. So you can tell a lot about DB2 subsystems without the DB2 instrumentation itself. And this is useful because, for example, most customers don't cut a counting trace for every subsystem all the time. And I like scalable methods that you know, no matter how many DB2s you might have, you can still apply the method. Even more so with Kixes, by the way. I mean, I've seen customers with over 100 DB2s, and I've seen customers with many hundreds, in some cases, thousands of Kixes. So there's a premium on doing things that are scalable. And typically SMF30 is the thing that enables that. So you can ask questions like, which subsystems are there? Well, that's fairly basic. And in particular, in which data sharing groups? And then what is it that attaches to them? And when is the subsystem maintained? So spikes in CPU for a subsystem address space might well tell you when utilities run, or something like that. So a lot of these questions can be answered without going to DB2 instrumentation, and they're beyond just performance. So here's an example. This is a very real customer. I'm desperately trying to remember who. Where from the SMF data, you can see two things. You can see a data sharing group in the Sysplex called DB0P. And you can see another subsystem that's not in data sharing, presumably for a completely different purpose. And we can see across 6 machines, not machines, 6 Lpars, SysA through to SysF. Yes, I have renamed. You can see a bunch of data sharing members, one on each Lpar. So that's what I would consider an architectural artifact. So we've got Sixway data sharing. We're not sharing Lpars between the data sharing members. That's quite a nice thing to know. So where do we get that from? Well, I've already said how we get the DB2 subsystems. We get it from the SMF30 for the DBM1 master and dist address spaces. The data sharing group names, well, we get the names of the groups from structure level SMF74 subtype 4, including duplexing schemes. So, there's a whole series of discussions you can have about duplexing. You could be talking about, if we think we've got white space in coupling facilities, are they really there for recovering structures, or have we duplex structures to the point that we don't need to consider white space for recovery of structures, which is actually a more complex conversation than I just made it out to be. We can also look at the request rates. So a data sharing group that hardly does any request rates to the structures is probably not so premium production as one that does a lot of traffic to them. And you might even take that down to the structure level. So a group buffer pool with hardly any traffic, might be less important, whatever we mean by important, than one that does a lot of traffic. And we can have conversations around lock structure duplexing. So with DB2 version 12 and a bunch of other prereqs, you might be able to get away with duplexing the lock 1 structure for a data sharing group. If I see it's not already duplexed, and if all the other stuff about distance and so on that we already know about. So 74 subtype 4 can be really handy here. Now, the actual membership of a data sharing group is usually done using SMF74 subtype 2, which is the XCF traffic record subtype. So for IRLMs, we see XCF traffic in two XCF groups, in a rather anonymous IXCLO and then some number of digits group, but especially the DXR group. So this is XCF groups where DXR is the first three characters, and then the data sharing group name is the rest of the group name. So that's fine. The problem with this one is it's actually the RLMs we're talking about here, not necessarily the DB2s. So this is where I end up falling back on pious hope, which is that the DB2 subsystems and RLM address spaces that serve them actually follow some kind of matching naming convention. And quite often that's not the case, but quite often it is. But I would hope people would have set up data sharing, well, DB2 in a way that the RLMs bore a striking resemblance to the DB2 subsystems in name terms. What's also interesting on this, and I didn't show it in that previous example, was sometimes you see a data sharing group where you've got one member that looks like DB2P as a name. And then the rest of the data sharing members in the group don't follow that name. So we don't have a DB2Q, RST, or anything like that. We have like DB012, whatever. And that gets interesting because then you can have a conversation like saying, well, did you by any chance start off not in data sharing mode with a DB2P for production DB2? And then did you go to data sharing, and did you decide, and I think this is probably the right decision, by the way, not to actually rename that original member to follow the new naming convention for data sharing? So that's tourist information. I think it's kind of nice to take those tangents. To understand the origin story, if you like, of this data sharing group. And sometimes you find there's members missing, like, for example, DB01 might be missing. Well, we started off with that one and we only bring that one up in an emergency, or whatever the story is. Again, that's not performance, that's, if you like, architectural or operational insight. Okay, now the next one is, so we've talked about data sharing groups, we've talked about members, DB2 subsystems. It'd be nice, without going into DB2 instrumentation, to get some insight into what this data sharing group member is for. Now, this is, I'm going to say, unscientific, but basically from the usage data section, let's say for a KICS region, and this is thoroughly KICS here, you see the DB2 it attaches to. Now, what I've done here is I've taken the CPU for that KICS region and added up all such KICS regions that attach to each of the DB2s, just to get a flavor of what typically is attaching to any given DB2. And I've added in actually DBM1 and master address spaces, which is the orange bit here. So this set of data sharing members is very thoroughly KICS. Now, you don't take the numbers too seriously in terms of usage of DB2. So back to something I said earlier about QRTCB. If you take out the QRTCB, maybe the most of the rest of that would actually be in DB2. So this is going to overestimate how much CPU is in DB2 by some margin. And the purpose isn't really to go with pristine numbers. It's to get a flavor, which says, look, this data sharing group basically is got out by KICS, at least in this time frame. So I think that's kind of a nice thing to pull out. Now, obviously, other times of day, you might find it's predominantly batch. And the batch here is gray. Well, during the day shift, here's the gray batch. During the day shift, we've got very little actual batch, but overnight, it might be a different story. And there's probably other ways of slicing and dicing this. Now, this, as I say, is a good broad brush approach. It uses the caller's SMF30. Now, one of the problems here is you could, in principle, from usage data section, get the CPU in DB2. However, most customers have turned off SMF89 style usage data, IFA usage recording in DB2, supposedly to save CPU. This is something called no89 as DSN ZPARM parameter. So you have to be very careful about this. And I recently saw a customer for MQ who actually, well, MQ is different actually. You can't turn it off in MQ, but I recently saw a customer who actually had DB2 data where they hadn't turned off SMF89 recording. So you could get more accurate if no 89 isn't specified. But in any case, you get a flavor of what attaches to DB2 and what attaches to MQ without necessarily going into details of exactly which CICS regions attach at this quite high level. Be careful about MQ because you will see a chin address space which will be very light on CPU compared to, let's say, a CICS address space. So there will be a bias here towards saying all the traffic to this MQ is CICS, which almost certainly isn't right. So you have to be careful if you try this technique with MQ, except for at least you know you've got CICS attaching to MQ, or maybe it's batch, so-called batch, or maybe it's IEMS. And one of the things I quite like to do sometimes is show this is coming back one, this is the absolute view of CPU, warts and all. Well, you might show the relative, let's have everything add up to 100% stacked bar view side by side with it. And sometimes I do that. Okay, now the next one is a bit more solid actually. So I mentioned earlier DDF and independent enclaves. Now this is a very nice result indeed, I think. And we use this in almost every study that we do to really bring out the role of DDF, which kind of creeps up on a lot of customers. So in SMF30, for the dist address space for a DB2 subsystem, you will get independent enclave CPU and independent enclave transaction rates. And all I've done here is I've plotted the independent enclave transaction rates by time of day across a week. Now, this is very scalable because we're using SMF30, not SMF101, subject of a presentation later in the week. And actually, I think I put this slide in there again, just for context. So here we can see a fairly regular pattern. And we can see it across a number of data sharing group members. Actually, this is a case where we don't have a 1 or a 2. We have 3, 4, 5, and 6, which enables me to remember who this customer is. So a very regular pattern across the week. We also have not that much evidence of bias towards any particular data sharing member. And remember, this is not from DB2 instrumentation. This is pure and simple from SMF30. Anybody could do this. And as I say, I mean, I start conversations with customers with, you do realize DB2A is doing rather a lot of DDF, don't you? Oh, is it? Well, yes, it is. And given that, you really want to take seriously how to WLM classify DDF for this subsystem, if not all the rest. Righty-ho, off we go. Conversation started about classifying DDF. Okay. So as I say, DDF gives you enclave transaction rate, which is really commit rate in DB2 terms, enclave transaction CPU, and actually enclave transaction response time. You could get the total response time and divide by the transaction count, and then you would get the average transaction response time. And it would only ever be average because that's all you get out of 30. Now, if you want to go further on DDF, and you probably do, in fact, SMF72 subtype 3 for DDF service and report classes gives you the transaction rate, gives you the CPU time, and gives you lovely 14 buckets of response time values. So you can see a distribution which might help you setting goals. Now, the pair of them, SMF30 and 72 subtype 3, give a very good high-level architectural story around how DDF is used and where it runs. So you don't necessarily need to go to DB2 accounting trace to do useful work with DDF, but as I will show you, I think it's Thursday, there's so much more value if you actually do that. Okay, now let's talk about kicks. So, people talk about regions as terminal owning regions, AORs, application owning regions, data owning regions, and so on. Right? Those, I would say, are fairly fuzzy concepts. Yes, they're meaningful, but a region might be playing multiple roles. It might not be so cleanly architectured as that. One footnote, if you are using Liberty Java in a region, that will actually show up in an SMF30 usage data section for that region. And I've seen that happen a couple of times. Now, its software level isn't evident, but if you know, for example, well, if you know the Kix region software level, then there is concomitant with some level of granularity, Liberty Java level that goes along with it. I've already talked about cloning. I should probably talk about restarts. And before I do that, let me talk about virtual storage. So you can see for a Kix region, and this used to be a really big thing way back when some of us weren't born and some of us were very young still. Below the line, above the line, and above the bar storage. Well, back in those days, above the bar wasn't a thing, and above the line was only just a thing. You have to be careful though with virtual storage, because we're talking about allocated virtual storage. Doesn't really say anything about how Kix is using the storage. I've already talked about usage data section. Why aren't all my regions at 5.5? I would also say in the SMF30, you can see zip usage for a Kix region. And if you do, and it's fairly rare that I see this, it's quite a useful architectural thing to spot, because it indicates something modern is happening, whether it's Java or System XML, or maybe there are one or two others. So I could say, okay, so I see you've got some Java CPU for this region. What are you actually doing that's modern and funky or useful? Meanwhile, Kix Transaction Gateway, which I see with the program name of CTG batch, that's almost pure Java. So the zip usage numbers can be kind of interesting around the margins of this. So let me come back to restarts. I can't remember if I've got a slide on this, so apologies if I'm talking about something I've got a slide for later on. So restarts can be rather interesting. So for me, are you a customer who restarts Kix every night? If so, why do you do that? That's a good architectural discussion. If it's down for half an hour, why is it half an hour and not 5 minutes? Now that might be a performance batch window discussion, but again, I think it's what on earth are you doing in that time frame sort of discussion to have. So restarts can be kind of handy. I'll probably stumble across a slide that says that later on. Okay. I'm not going to take you through this slide in any real detail, but basically this slide was generated a couple of different ways. Firstly, I know which DB2 a Kix region connects to because the usage data section tells me that. The other way is I have report classes, I have service classes, which enable me at some level to color the blobs. In other words, classify the DB2, the Kix regions with similarly located stroke named other Kix regions. So if I don't read this out, but on the left-hand side, we have some regions that are in our Kik other, presumably other, and they're the only ones attaching to this DB2 that are in that one, and there are 3 of them. And on a different Lpar and obviously a different DB2 data sharing member in the group, there are 3 more. So there's something structural here about we have these set of regions on each DB2, and the green again even more so. Those are mobile regions because it says RKix mob, and presumably the description for that report class says mobile somewhere. So you can begin to build what's the Kix connectivity to DB2 and MQ look like. Here's MQ, by the way. And you can see this is a small part of the estate. But that's all scalably done from SMF30. In case you wondered, I used a tool called iThought. It's a mind mapping tool, which is a slight abuse of it, but who's to say what a tool's for either, to draw those diagrams. So I've kind of covered this, but there are a few other pieces in it. So I didn't touch on the second item, which is some of those regions have extremely high EXCP rates, which turn out to be for vSAN record level sharing, and SMF 42 subtype 6 corroborates this. So some of the regions are actually clearly data owning in some sense. Some of the average CPU consumption figures might worry you. I glossed over that too, but we've already talked about that. Some of the regions look like TORs just because they have T instead of A in the name, and they have a low CPU and IO rate, which might corroborate that. I also could have added XCF messaging rates. So, you can take KICS, DFH, IR 000 being the default KICS XCF group. That could be architecturally interesting as well. The other thing is these slides are obviously static pictures, the last two. So time of day could actually prove interesting as well. Okay, so very briefly, I said you could tell things like temporary storage server, data table service from the program name. Here's an example of doing that. And here's the CPSM CMASs as well, color coded, how nice. And actually there was a naming convention here for the CMASs relative to the Lpars they sit on, all from 30. Now in this example, there aren't any named counter servers. And there aren't any CTG address spaces, and there aren't any KICS regions that don't attach to either DB2 or MQ, which might be architecturally interesting. Okay, restarts. Here's the example I gave of it's about half an hour to restart these. They seem to do these every day. Now, why on earth is that? And the other thing I should say here, which I didn't say before, was, if they come down on a timer pop, you might detect that because of when that timer pop is. Well, look, every day, more or less, they come down at exactly the same time to the minute. That might imply something about automation here. And maybe that automation is obsolete because we no longer need to take them down. Who knows? Okay, IEMS it is very similar. I'm running a bit short on time here. It's a bit more difficult to work out exactly what connects to what with IEMS, I think I would say. But at least you know the IEMS levels of things, and you know things are using IEMS down to the step level. Okay, ZCX container extensions, very briefly now. There's a program name, as I said before. The memory is long-term page fix. You may well see that. You may well see a lot of zip. One caution here, architecturally, we don't know what's in the ZCX instance from SMF, because the SMF30 basically is the whole address space. Now you have to use Linux's own instrumentation. And actually this red book, I think, I read the chapter where it talked about Linux on Z's own instrumentation for looking inside a container. These you want to watch out for, I think. I think you probably want a query that says, oh, do we have anything with program name GLZBAIN? Okay, IO subsystem, I would say we really don't have time for, but you can drill down from the instrumentation to pull out a very good representation of the IO subsystem connectivity topology and performance. One very interesting question I will pull out on this is a question I keep asking customers from the data, which is, why is this channel rated at 16, but it's only going at 4? And quite often the answer is, well, we're on our way to refurbishing the fabric in some way. And we know we're only running at 4, even though we could run at 16, so we're getting there. It's these wretched switches or something that stops us. Now, SMF73 Gen is a code. It's a 1-byte code which gives you the maximum value for the channel and its negotiated data rate. And SMF73 is the channel path activity report data, of course. So there are some interesting architectural discussions, and where are you in moving forward kind of discussions that this data will give you that aren't really that much related to performance. Okay, So the bottom layer, which I think we're going to go into much more next time, you know, from DB2 and MQ accounting trace, you can get very gutsy about who is connecting and how it's performing. And a lot of what's on this slide actually is in the DDF presentation I'm giving on Thursday. I will say Kix monitor trace, most people really don't tend to have because it's voluminous and thought of as expensive, but it is very detailed. So there is another layer. And similarly, data set names can be very useful. If you want to do more detailed things about, you know, what databases are active on a DB2, for example, the 42 subtype 6s will give you a lot of that information. So let's just finish off with how does this actually address the question of whether you're an architect or not. I think it says you probably aren't an architect, which we all knew, although some people on the call might actually be architects. But the role you can play in architectural discussions as a performance and capacity person can be very valuable. You can understand what's actually happening, what's really going on. So that could make you, if you're a performance person, valuable to architects. Architects, if you're listening, you know, your performance people can give you a lot of this insight. It enables you to keep an up-to-date view of the estate when maybe nobody else really has an accurate one. I also think that it can help you do your day job of performance and capacity because you know what these components are and how they relate and how important they are versus how important they aren't. And explain some of the behaviors you will see in headline numbers for capacity and performance. Now, for me, dabbling in architecture like this, and I will admit it's dabbling, but I think there's a lot of value in it. It keeps me interested. It's not that performance and capacity are boring to me. They certainly aren't. It just provides another angle. And, you know, on the data, it enables me to have other conversations with customers than I might otherwise have. And it gives me actually another way to find patterns between customers. So I think this is a very fruitful approach, which is why I've spent an hour and a bit now talking about vaguely architectural stuff, maybe operational stuff, more than performance and capacity. And I will say, as a final thought on this, I'm seeing increasingly complex mainframe estates. I'm seeing, in numerous cases, hundreds, if not thousands of Kix regions, lots and lots of DB2s. You might be alarmed how many DB2s you've got. Paul, cover your ears at this point. You know, many MQQ managers, and ever more diverse DDF work, some of which his presence might actually surprise you. So I think keeping track of it all is really, really tough. If you try and do it manually or some bookkeeping exercise, it's really, really tough. And this is true whether you're a large estate or a small estate. So hopefully some of the techniques I've outlined here are ones you can use to do some really valuable work outside of or abutting maybe the performance and capacity role we all think we're doing. So with that, I will take a quick look at any questions that might have come in. Okay, right. I see somebody's actually asked a question which could be a whole presentation and has been in its own right. So let me just get past the Wi-Fi issues one. Okay, so as people identify themselves by their names, and I know them, I will say thank you, Mary, for your question. So which SMF records are the best place to check workload or address space central storage occupation? This is the long question. Well, it's a shortish question, but a long answer could be had here. So let me try and summarize it. The most trustworthy places for memory instrumentation in order from best to worst is SMF 71 at the system level, then SMF 72 subtype 3. And the issue here is if you are logically swapped in central storage, your pages are not counted while you're logically swapped out. Did I say swapped in? I meant swapped out, logically swapped out. So that would underestimate TSO and batch to name 2 workloads, but that's not bad. And report classes are a very fine way of doing this as well, which could take you down to address space level. So the worst one is SMF30. This is slightly tails out of school, or maybe it's thoroughly tails out of school. SMF30, I really don't trust the numbers for real storage in them. I do trust the allocated virtual storage, which you might consider a poor proxy for real storage usage by the address space. But I think, frankly, for most cases, I would be using a really good report class structure, maybe, well, yes, report class structure, possibly service class structure, although really we want you to use service classes for actually controlling performance. So I would say probably the net of this is report classes, but watch out for things like batch and TSO. So hopefully that's the shortest but most helpful answer to that question. Okay, the other one from Simon is, what's the, okay, Stephen, you got me there, RMF Monitor 3, if you use it, that should be accurate on a time interval basis, time by time basis. Yes, fair point, Stephen. Now, the other question from Simon was, what's the tool I use for the diagrams? It sounded like iThought. Right. It's my accent, isn't it? I'm going to spell it out. Actually, why don't I type it in? I typed it in. Oh, right. I only went to one person. Let me do that again. Where's everybody? Everyone. Right. The name of the thing I used, and you don't have to use this one, it's a mind mapping piece of software called iThoughts. And slightly more detail, I create CSV files with a structure to them. This could be actually an advert for one of my open source projects. But anyway, I create a CSV file in my Rex code in a tree structured manner that I pull into iThoughts and then fiddle with the coloring and so on. iThoughts is a mind mapping piece of software. And I've kind of hijacked it to give me a tree view. So the tree might be Sysplexes, Lpar, DB2 subsystem, KICS region, which you can obviously think of as having a tree structure. So I'm using a tool called iThoughts. It's called iThoughts X on Mac OS. If there are better ways of creating trees, and I think digraph is one of the ways, somebody would probably say D3 also. Doesn't hugely matter, but I'm telling you what I use because it will import CSV, which for me is a very valuable thing, including coloring, by the way. So the diagram with the KICS adjunct address spaces like data table server and so on, that's actually colored in my code in the CSV I import into iThoughts. So that's how I'm doing it. You could probably do it with FreeMind, though I hate FreeMind's way of laying things out. You could probably do it with MindNode. There's probably a bunch of others. But automation is the key thing here, which is why I'm using iThoughts to answer that question. Okay. So there was another administrative question, which is a copy of my slides available? Well, hopefully, I mean, Piara, maybe you can answer this better than I can. Hopefully, there is the presentations are available to all.
Yeah, that's right. So if you go on the agenda and click on the little magnifying glass on the session, there will be a link once you scroll down to the to your slides.
Okay, cool. And by the way, people can always talk to me. Hard to avoid me, I would guess. Can always talk to me offline if they want to. And you may well have your own views of how to push the architectural envelope. You might say, now come off it. This isn't architecture, this is operations. Fine. Philosophy is us. Okay, right. Anything else before we close, given that we're 10 minutes over, but I'm perfectly happy to take one more if there is one. And I don't see any more right now. Okay, so thank you very much, everybody, for your time, and hopefully a bunch of us will show up again on Thursday. And if there are questions in the meantime, I will actually briefly address them on Thursday if they're of general interest.
Thanks so much, Martin. We really appreciate your time. Very insightful presentation, and really like the examples as well. As a reminder to our audience as well, feel free again to leave some feedback. Really appreciate that. And obviously, any donations, big or small, to our chosen charity, NHS Charities Together. I've dropped a link in the chat box as well. Yeah, would highly appreciate your donations as well. And thanks again for attending. I hope you all have an enjoyable rest of the day.